All right, we are going to do 1/6. The warm-up is the Pythagorean identity that we did yesterday. So you would do the 4/5 squared. They gave you sine, so then you're finding cosine squared, and then that equals 1, and then you're going to have to go ahead and solve that out. I'm not going to finish that, because we got a lot to get through. So you need to finish that before you turn your notes in. We are doing special angles today. So far we only know how to find the sine and the cosine of our quadrant angles, or the axis angles, the ones that actually fall on the x or the y axis. So we know the sine and the cosine of these angles that fall directly on the axis, but we don't know all these little angles in between, okay? So the goal is today to be able to find the sine and the cosine of all of the angles in between the axis angles. Okay, we're going to do 3 angles in each quadrant in addition to the ones that we already know. Okay? So these angles and their sines and their cosines come from your special right triangles, the 45, 45, 90 and the 30, 60, 90 triangles. Usually I would actually show you this and prove all of this to you, but I think that might be a little much to do in a video. So just understand these rules that you learned in geometry for these special right triangles. So for a 45, 45, 90, the lengths of the legs are the same because it's isosceles right triangle, and each leg is 1/2 the length of the hypotenuse times the square root of 2. So those were rules you learned in geometry. So 1/2 the length of the hypotenuse times the square root of 2. And remember, in our unit circle, our hypotenuse is always the radius of our circle, and so the hypotenuse is always 1. Okay, so keep that in mind. For a 30, 60, 90 triangle, the side length opposite the 30-degree angle is 1/2 the length of the hypotenuse, which again, the hypotenuse is 1. And the length of the side across from the 60-degree angle is 1/2 the length of the hypotenuse times the square root of 3. Okay? I'm not going to prove it to you. I'm not going to show you exactly what this looks like in the circle like I normally would, but it's just good for you to have an understanding of where these numbers are coming from, because they might look weird. They may be like, why is this the square root of 3 over 2? Well, that's why, because it's 1/2 the length of the hypotenuse times the square root of 3. That's where the numbers are coming from your special right triangles, so just be aware of that. We're not going to do all of this. We're going to skip some of these. Just remember that the triangles are inside our unit circle. So if this is 45 degrees, your hypotenuse is always 1 because it is your radius. And then these legs are going to be the same, and they are 1/2 the length of the hypotenuse times the square root of 2. So the square root of 2 over 2, the square root of 2 over 2, because your hypotenuse is just 1. That's what this is looking like, okay? So we'll come back to this in a second. This chart that you're going to be using that's what it's all based off of. That's where all these numbers are coming from. We are not going to do tangent yet, so you don't have to pay attention to the 3rd row. But the first 2 rows, the 0, the 1, and the 1 and the 0 on the right hand side, those are your axis angles, so you know those already. But all of these middle numbers, the 1/2, the radical 2 over 2s, and the radical 3 over 2s, are all coming from those 45, 45, 90, and 30, 60, 90 triangles. So that's why they are the way they are. Those are the numbers, okay? We first have to figure out how to find what we call a reference angle. So we can use that chart I was just showing you to find the sine and the cosine of all of these quadrant 1 angles, 0, 30, 45, 60, and 90. But the nice thing is that if a reference angle, if we have an angle in quadrant 2, so say we have a 150-degree angle, okay? That's a quadrant 2 angle. it pairs with 30 degrees. So the sine and the cosine of 150 and the sine and the cosine of 30 degrees are the exact same numbers. The only thing that might change is whether they're positive or negative. So if we can learn how to find which angle it pairs with, they're called reference angles. So we need to know how to find the reference angle for each of the major angles, and then that way we can just use this chart and know the sine and the cosine of all of the angles in between. Okay? So, a reference angle, okay, if it's in quadrant 1, it's just the angle itself. Nothing fancy about that. So remember, we use the Greek letter theta to talk about angles. So if we're talking about how to find reference angles, if you are in quadrant 1, it just is the angle. You don't have to calculate anything. You just find the 30, the 45, the 60, the 90 degrees, sine and cosine. If you're in any of the other quadrants, you have to calculate it. So this piece is really important. Reference angles are the distance in degrees from the terminal side of the angle to the x-axis. So right here is a 150 degree angle. We've got the rotation inside. And this is my terminal side. That's the end, correct? That was my moving ray. That's the terminal side. The reference angle is going to tell us how far away we are to the x-axis, because the whole goal is to make these right triangles so that we can find this point out here as the sine and the cosine, just like we were with the other angles. So we need to know these legs in order to find this point. So the angle is the distance from the terminal side to the x-axis. Okay, that's what we're looking for. That's our reference angle. So if we think about it, if we would rotate, if you rotate all the way down, it's 180 degrees to the other side of the axis, okay? So we're not going quite 180 degrees. We're going 180 degrees minus this 150 that we already went. That's how we're going to find the little distance that's left, is 180 minus 150. So in quadrant 2, to find the reference angle, you do 180 minus your angle. So if you are given a quadrant 2 angle, you find the reference angle by taking 180 and subtracting theta. So I'm in quadrant 2, I find my reference angle by taking 180 minus theta. So in this case, we're going to do 180 minus our angle, which was 150, and 180 minus 150 is 30, which is what we have over there on the right, okay? 180 minus 150 is 30. So then that way we just need to know the sine and the cosine of 30 degrees. We don't have to know the sine and the cosine of 150. Okay, we don't want to have to memorize all these numbers for all of these pieces. We just want to be able to do it for the first quadrant angles, and then we can refer back to them for everything else. So the sine of 150 and the cosine of 150 are going to be the same as the 30, okay? And we're going to learn how to memorize it, and you will memorize this chart. And I'll give you a trick in class in a couple days, but for now you can just use this chart. So we're looking at the 30, so the sine is 1/2 and the cosine is the square root of 3 over 2, okay? So the sine is 1/2 and the cosine is the square root of 3 over 2. The only thing that you have to do on your own is you have to know what quadrant you were in originally and know whether it's positive or negative. It's all building on what we've been doing. So we are in quadrant 2. So in quadrant 2, the x value is negative and the y value is positive. So that makes sine positive because it's up, but that makes cosine negative. That's what you have to be able to change, okay? And those are your answers. We didn't have to calculate, we did not have to calculate anything. The only thing we had to know is how to find the reference angle and then whether it was positive or negative, and the chart tells us the rest. So let's look here. 225 degrees. Again, reference angle is how far you are from the x-axis. So we're looking for that little piece, okay? The way that we're going to do that in the third quadrant, you're going to want to write one of these. One of these little charts with telling you how to find the reference angles. It's going to be important. So quadrant 3, the way we're going to find it is we're going to do theta minus 180. So it's just flipped. So in quadrant 2, you do 180 minus the angle, and in quadrant 3, you do the angle minus 180. So we're going to do 225 minus 180, and we get 45. So the cosine or the sine of 225 and the cosine of 225 are going to be the same as they are for 45. So all we have to do now that we know what our reference angle is we look at the chart and we find what it is for 45. 45, 45, 90 triangles have the same legs length, so the sine and the cosine are going to be the same. They're both the square root of 2 over 2. So both sine and cosine are radical 2 over 2. Radical 2 over 2. The only thing you have to do is know whether they're positive or negative. We are in quadrant 3. Everything in quadrant 3 is negative, so they're both negative. And then you're done. So this chart is going to be important. I would suggest you take a screenshot of it so that you can put it in your homework. You can move it down in your notes. Take a screenshot of this table. Again, you don't need the tangent yet. If you want to draw a line through it, you can. But you do need the sine and the cosine right now. We'll do tangent later. Okay. Once you know how to do all of that, this is called a unit circle. And this looks overwhelming, but you know how to, you can find all of this now, every single one of these things. The inside of the unit circle are your degrees, which you know, and your radians, which you know how to change from degrees to radians and radians to degrees. So you can do all of that. Done. The outside of the circle are the cosines and the sines that we already found. So these on the axis are the ones we knew how to do a couple days ago. Cosine, sine, cosine, sine, cosine, sine. The x and the y coordinates. Okay, we knew that. And the other ones, these other ordered pairs, are just new to us today. These are what the chart will tell us. Okay? So this, we know how to do all of this now. Which it looks overwhelming, but you've learned it all in just a couple days. Okay? This is what we're going to do. We're going to find the reference angle, and then we're going to find the sine and the cosine, or then we're going to find the answer from there. Okay, 120 degrees. Let's bring, oh, we didn't do quadrant 4. Sorry. Quadrant 4, to find your reference angle, you do 360 minus theta. Okay? You need that. Bring it on down. Okay. 120 degrees. What quadrant is 120 degrees in? It's between 90 and 270, so it's in quadrant 2. So we're going to do 180 minus 120. Okay? 180 minus theta because we're in quadrant 2. 180 minus 120 is 60. So my reference angle is 60. This is asking specifically for the cosine. Okay? So the cosine of 120 is going to be whatever it is for 60. It's the same thing. So we can look at the chart. I brought it down already. The cosine of 60 is 1/2. So the cosine of 120 is 1/2 because they have the same number. The only thing is we're in quadrant 2. Is cosine positive or negative in quadrant 2? It's negative because x is negative in quadrant 2. So you found the reference angle, you found the reference angle on your chart, that was your answer. Then you just had to think about positives or negatives. Okay. Pi over 6, if you don't like it, you know how to change it. Multiply it by 180 over pi, and you get 30 degrees. So we are looking for the sine of 30. What quadrant is 30 degrees in? 1. So in quadrant 1, you don't have to do anything special. It just is what it is. So we just have to find the sine of 30 on our chart, which is 1/2. Everything in quadrant 1 is positive, so you don't even have to worry about it. Done. All right, sine of 300. What quadrant is 300 degrees in? 4. So this is how we're going to find the reference angle. 360 minus theta. So 360 minus 300 is 60. So the sine of 300 is going to be the same as the sine of 60. Oops. So let's look for the sine of 60 on our table. It is radical 3 over 2. Square root 3 over 2. But what's the only thing we had to think about ourselves? We are in quadrant 4. Is sine, which goes with y, positive or negative in quadrant 4? Oops, sorry. It's negative because we went down. So it's negative radical 3 over 2 for 300. Done. Sine of negative 60. When you have a negative, it's because you dropped down. So if I'm in my standard position and I drop down 60 degrees, I'm still in quadrant 4. But my reference angle is 60 because I only moved 60 degrees away from that axis. So it's going to be the same as 60, but I just know I'm in quadrant 4. So the sine of negative 60 is the same as regular 60, which is the square root of 3 over 2. That's what we just did. Except, what quadrant are we in? We're in quadrant 4. And we just said sine's negative in quadrant 4. Then you're done. Be careful, I just want to reiterate that this is not negative because this is negative. That is not true. It is negative because the negative 60 meant we went down and we ended in the 4th quadrant, and sine in the 4th quadrant is negative. It is not just, oh, that one is, so the other one is as well. That's not how it works. Cosine of 30, easy peasy lemon squeezy. We are in the 1st quadrant. It just is what it is, theta. So the cosine of 30 right here, radical 3 over 2. And guess what? Everything in quadrant 1 is positive. So you're done. Done. Okay? So find your reference angles, find it on your chart, and then know whether it's positive or negative. So these are the 2 things you need, well, to do your homework. Well, I scribbled all over this one. You need this and that. You need to know how to find your reference angles, and you need the table. And then you also need to know when sine or cosine are positive and negative. Good luck.